Yeah, but the whole point of having thorium reactors is that they can't go kaboom. I'm sorry, if that was the point of thorium reactors, then thorium reactors would have no point. And thorium reactors can go kaboom. I don't believe that they would, but they most certainly can. And explaining why requires some basic reactor physics. And so explaining this is going to take a little while. We're going to have to talk about some real reactor physics to explain how you can go from delayed critical to prompt critical, whether it's a thorium reactor or a uranium reactor or a mixed oxide reactor or whatever. So let's talk about criticality. Criticality is the process by which, when you're doing fissioning, the fissioning nuclei give off neutrons, 2 or 3 neutrons, which are enough to go off and cause fissioning in other nuclei in a sustainable fashion, so that it's at a constant rate, so that the fissioning is at a constant rate. Now, technically, that's not legal in the United States. You are not allowed to operate a reactor where the fissioning neutrons are sufficient to maintain criticality. You have to be in what's called delayed critical, meaning that if you're just using the fission neutrons, the reaction will peter out and it'll go to zero. The delayed critical region that you're allowed to legally operate a nuclear reactor is where you have to have the radioactive decay of fission products give off neutrons to have enough neutrons to maintain a critical chain reaction. In other words, some fission products that are generated in a nuclear reactor actually decay by neutron emission. And when that happens, those neutrons are folded into the neutron economy and then contribute to subsequent fissions and the critical process. That's called delayed critical. So the amount of reactivity between exactly having no delayed neutrons in the process, these radioactive decay neutrons, and being exactly at critical, we call that measure of reactivity a dollar. And so you're never allowed to change the reactivity of a core by some fraction of a dollar, maybe a dime or a quarter or something like that over a given period of time, to make sure that you never go into prompt critical. Now, prompt critical is the bad place. Prompt critical means that you put in too much reactivity so that you no longer need the delayed neutrons, and then the reaction will exponentially increase and you'll get a disassembly of the system. And even worse, you can get a phase change. The phase change is where you go kaboom. That means you have a prompt excursion and it disassembles itself explosively, like what happened, for example, at Tokaimura, or more poignantly, what happened at Chernobyl. They pulled out their control rods, and they pulled them out. They were out too far so that when the reaction took place, it went prompt critical and the water flashed to steam. That flashing to steam caused the disassembly. Tokaimura is something similar. You get boiling. But you get the point. It will disassemble if you go into prompt critical. You're only allowed to operate in delayed critical. Well, how could you go into prompt critical with a molten salt reactor? Well, 1, you put in too much fuel, Tokaimura. 2, you have the control rods pulled out too fast, Chernobyl. And so everything is in place for you to have a disassembly of a molten salt reactor as within any other reactor. There is no difference. There is no difference other than that you're using a different fuel cycle and you're using a different fissile isotope, which means that there's some small changes in the fission products and really not of substance to really discuss that in this context. So there's a lot of false hype out there about thorium reactors. Thorium reactors are great, but they're not a magic bullet. I think it would be a bad idea to just replace all uranium with thorium reactors. That would be stupid, in my opinion, because we've got all the infrastructure for uranium. We don't have the infrastructure for thorium. Thorium would be great. It would be lovely to bring that online in addition to uranium. But the false hype out there is just that. It's false hype.